Greetings to all the lecturers who are going to evaluate my presentation and all my fellow friends. In this video, I would like to present what I have done in IDP2 as a member of Group 16. My name is LiewChiaMing and I have been assigned as a member of the root department. As you can see, here are the tasks that I have been done in IDP2 and I will explain them one by one in this video presentation. The root network system is one of the most significant infrastructure in every country as it supports both view and pedestrian traffic. Here are the root type, root standard, and also the root category in Malaysia. The guideline and the design standard that I have used in IDP2 are also shown as below. Next, for the project site information, the location of the site is clearly shown in the slide. The number of buildings proposed in the project is listed above and it will be used to estimate the trip generation later. The population at the shelter project are roughly 360,000 in the years of 2010 and thus it can be concluded as an urban area. In order to estimate the average daily traffic ADT, we need to obtain the data from the census station. The census station JR202 is chosen as it's the nearest to our project area. The location of JR202 is shown above and all the data is obtained from the RTVN 2017 and thus the ADT estimated is the ADT in 2017. So a series of calculation is needed to be done to get the estimated current ADT. Before that, we need to examine the topography of our project area. There are three types of terrain which are flat, rolling, and mountainous. The criteria and the formula of G are shown above. The vertical and the horizontal distance are taken from the drawing and based on the proposed level by the effort department in IDP1. So as a result, the topography for the project area is all considered as flat terrain. For the ADT, the data and the information obtained from the census station JR202 are shown in the slide. By using the above formulation, we obtain the ADT for the years 2017, 2022, the current year, and also 2042 as the design period is assumed to be 20 years. By considering 5% of the traffic volume is under the major route and 3% of them is under the minor route, we obtain roughly 20,000 vehicles per day in major route and is classified as U5 collector route. For minor route, it's only 625 vehicles per day and classified as U2 local street. The design speed is 60 km per hour and also 40 km per hour respectively based on the table below. This is the existing ADT obtained without considering the project proposed. In order to get the ADT with the inference of project, we need to consider the trip generation. The first step is to obtain the trip generation chart according to the type of building proposed in the project and generate the progression equation. The gradient is calculated and substitute into the general equation y equal to ms plus c to obtain the progression equation. The table below has shown the summary of the morning and evening progression equation of rumah cluster, rumah berkempat, rumah mampu biaya, and kedai penjabat, and also the percentage of in and out. By substituting all the dwelling units into the progression equation, we obtain the trip generation for both morning and evening. Since the evening trip generation is higher, thus is used to determine the trip generation for the years 2017, 2022, and also 2042. The traffic volume is equal to the summation of ADT generated from the census station and the trip generation of the development area. So by adding both values together, we obtain 58,000 and 8,000 vehicles per day for both major and minor route respectively. Thus, major route is classified as U5 collector, with a design speed of 70 km per hour, and the minor route is classified as U4 local street with a 60 km per hour design speed after we consider the proposed project. Next, let's move on to the determination of the number of lane. The first step is to calculate the heavy vehicle adjustment factor FHV by using the formula below. By adding all the proportion car equivalent of truck and buses and substitute all the value into the formula, the FHV of the major route is 0.94. Substitute all the data into the formula, we obtain that the number of lane required for the major road is 2 for each direction. Thus, a 2-lane carriageway route will be designed for major route to sustain the traffic volume. For a side distance, is the length of the roadway a driver can see in any particular type. So there are 3 types of side distance, which is stopping, passing, and intersection side distance. The factors that affect the side distance are shown below. Based on the table from ATJ/86, the minimum stopping side distance for the major route proposed is 105 meters. Here are the types and formulas for the horizontal alignment. In this project, I only did one design of a simple circular curve and spiral curve for the major route. So the minimum radius required for the major route is 195 meters, and the remaining horizontal alignment will use the same design as well, but maybe with a different theta value depending on the site situation. So here are the design and calculation for the circular curve with a minimum radius of 195 meters and theta of 100 degrees. The above shows the calculation and the design outcomes of several important lengths of the circular curve. Next, here is the design and calculation for the proposed spiral curve for the major route with 25 degrees of the theta of the circular curve. The summation length of the transition curve and also the circular curve is equal to 137 meters as shown above. For the vertical alignment, it was employed to achieve a gradual change in tangent grades. The crest and shade curve are 2 forms of vertical curve. The grades meeting at the summit define the crest curve. The gradients meet at the through forming shade curve. Since the terrain of our development area is flat, and thus there's no design for the vertical alignment in this project. The above diagram shows the load distribution pattern by the view load on the road. So for the pavement design, the equivalent standard axial load ESAL is determined to obtain the traffic category. By substituting the land distribution factor and also the terrain factor into the formula, we obtain the ESAL in the years of 2022 and then forecast for the year of 2042. Thus, the traffic category is T3 based on the ESAL determined. A minimum recommended CBR value of 5% is used in the pavement design, and thus the subgrade category is SG1. The above diagrams have shown the location of roof pavement and their respective thickness. Here is the pavement design proposed for the route, and there are 4 layers proposed, which are sub-base cost, road base, binder cost, and bearing cost. The description and the pavement thickness of each layer are shown in the slide. Next, let's move on to the intersection design for the major road. To decide whether there's a need to propose a signal control system at the junction, we need to do at least 3 warrant checks. For warrant 1, vehicular operation. The minimum requirement PCU for both major and minor routes is shown in the slide. If the 8-hour traffic volume is exceeding the minimum requirement, thus there is a need to propose a signal control system at the junction. Here is the Warren Chart 1 for both major and minor roots, and it clearly showed that the PCU value for the major root is 987, which had exceeded the minimum requirement 600. Thus, there's a need to design a signal control system at the intersection. Next, for Warren 2, penetration safety, and Warren 3, accident record. There's no records are attended, thus the analysis cannot be performed. However, it still required to design a 3-arm junction traffic light system, as it did not pass the check of Warren 1. The traffic volume at the junction is shown below. The first step for the intersection design is the phase check. The phase at the traffic is first checked for 2 phases, and it was found that it is not sufficient due to the traffic volume between east and west had exceeded the limit. Thus, a 2-phase cycle is not suitable for this junction. Thus, a designation of 3-phase cycle traffic system is proposed at the intersection. The calculation of effective green, actual green, and the displaced green period are shown above. Here are the phase diagram proposed, and the full calculation can be found in the full proposal report. The same design procedure will be used for every intersection of the major route. The last part of our route design is to propose a correct placement of signage, curb, median, route marking, and street lights. Due to the time constraint, I only show few types of route signage in the slide. The remaining route furniture can be found in our full projects. Here are the drawings from the route department. The drawing at the left shows the location of the main entrance, major route, minor route, and also the location of the signal control system at the junction. The diagram at the right shows the proposed route network we control. The black color indicates the proposed route network. Here is the traffic circulation in the route network. As you can see from the slide, there are 4 right-of-way proposed in the development area, which is the route with 80 feet, 50 feet, 40 feet, and 20 feet. The cross-sectional design of each the route is different according to their right-of-way. Next, this drawing shows the route level at the intersection. The route level is proposed accordingly to the platform level proposed by the Earthwork Department in IDP1. The overall terrain type is flat as shown in the diagrams. The following drawings are the cross-sectional view of route reserve 80 feet and 50 feet right-of-way. For the route reserve 80 feet, it consists of a driveway with double length, a car park, and a drain for each direction. For the route reserve with 50 feet, it only consists of 1 lane for each direction. Both of the route is designed with a very small slope with the ratio of vertical to horizontal distance 1:40 to allow the flow of rainwater to prevent the occurrence of water ponding on route. Next, here are the cross-sectional drawings for route reserve 40 feet and 20 feet right-of-way. For the route reserve 20 feet, the route is only designed as one-way carriageway as bad lane. Lastly, here are the intersectional design for both major and minor route. It shows the lane width, median, and the location of traffic light and signage. So with that, that's all for my IDP2 video presentation. Thank you for spending your time watching my video, and thank you to all the lecturers and friends who have always helped me in the task.